Hello everyone, my name is Timothy Lee Grant and we are back with another LeetCoding video. Every day doing a LeetCode problem. Today I went on a crazy adventure. I am absolutely exhausted. I don't want to be doing a LeetCode, but every day LeetCode means you don't stop, you don't quit, you don't take a day off. It's not like, oh, I'm feeling tired, therefore I'm just not going to do something. If you set a goal, you have to continue with it. So doesn't matter how tired you are, doesn't matter how what's going on. Set a goal, just do the goal. So I said I was going to do a LeetCode, at minimum one LeetCode every single day. So that's what we're doing. Exhausted, but let's go. All right, so we're doing heaps. Okay, heaps, and let's we did, I think, 3 easies. How about we do one more easy just to kind of get us really comfortable with kind of how heaps work, and then tomorrow I think we're going to be able to start jumping into some mediums. So let's do this one. Clicked on it too quickly. All right, 1 4 6 4. Maximum product of 2 elements in an array. Okay. Given the array of integers nums, you will choose 2 different indices, I and j, of that array. Return the maximum value of nums of I minus 1 times nums of j minus 1. Okay. All right, so I guess that's the entire problem statement. Kind of a very short problem statement. To be honest, I understood about 2% of it, that there's a nums array and we're supposed to do something with it. And we're indexing I and j. Let's reread that question and try to get more information. All right. Given an array of integers, nums, okay, so we have a nums list, and it has integers in it. You will choose 2 different indices, so I am allowed to choose 2 indices, I and j, of that array. Yep. And my purpose is to return the maximum value of nums of I minus 1 times nums of j minus 1. So this is going to evaluate to an integer, and then I'm subtracting 1. Okay, this is going to evaluate to an integer, and I'm going to be subtracting 1. And then I multiply them together, so it's a multiplication, and I'm just trying to maximize that. Why is this difficult? Because can't I just search this nums list for what is the maximum value in it, and then just select that to be my I and j? And normally, I and j are actually going to be the same number. It's just the highest value. So like this one, 3 4 5 2, I is 5, j is 5, or I is 0 1 2, j is 2. So they're both pointing to this 2 index, which is 5. 5 and 5 is... How the heck did they get 12? Hold on, what? So 5 minus 1, 4. Oh, 5 times 5, 25. Not adding. Not adding. There we go, yeah. 4 times 4, yeah. Right? Okay. So I guess you're not allowed to choose it, so it's like 3 times 4 and comes out to 12, not 16. So that's why they got 12 instead of 16 here. But in the problem statement, it doesn't say that you can't have I and j not equal to each other. So that's a little bit... Okay, anyways. I have no idea how or why a hash or a heap has anything to do with this. It just seems like you can go and search for the maximum element, and then I guess you need the second max element. Oh, okay, well, I mean, a heap, that's, I guess, the purpose of a heap is to get the maximum or minimum element, and you pop it twice, and then you have, okay, actually, yeah, sure, I guess a heap does work in this situation. So, going back to those things that we said that we need to kind of keep focus on, one of the things is when we see a problem, how do we know that let's pretend like we didn't know that it was part of the heap like category. How do we have identified this problem here as heap? And one of the things that I'm seeing is, okay, when I was explaining the problem to myself or to the video, I was saying the top two elements, right? Like the biggest two, and that's kind of a key that we need heap. So I guess what I can do is just start coding. So are we guaranteed that we do have two indices? The length of nums is 2. Okay, cool. So we are guaranteed that we have at least 2 elements in nums. So I'm going to do heap q dot heapify. So I'm creating a heap, and I'm going to operate on nums. Now I am going to num1 equals heap q dot heap pop, okay, and nums num2 equals heap q dot heap pop nums. So this does have a problem that it's actually returning the smallest element. So I actually might need to just negate everything. What I'm gonna do is my heap equals, and then like this. So negative x for x in nums. And then I'm just going to put this. So I'm taking all of the values in nums, and I'm just making it negative, and I'm storing it in an array called my heap. And then I'm just going to take that heap, that list that I just created, heapify it. Then I'm going to pop off the most negative number, which is actually the biggest number, right? And then I am going to pop off the second largest negative number, which is the second largest number. Then all I need to do is kind of negate the two. So now in the calculation, I'm going to just follow this calculation. So return, and then do I actually need the index anywhere? No, I don't think I need the index. I just need the actual value. So I'm going to do num. I'm going to do like this. So negative num 1 minus 1, and now multiply negative num 2 minus 1. So following this equation, but I need to negate each of these numbers because I stored this is going to be like the biggest negative. So I'm just like inverting that. So let's see if that works. All right, cool. It worked. Anyways, thank you guys for watching this video. If you liked it, subscribe. My name is Timothy Lee Grant, and I am out of here. I did it. Okay. I said I was gonna do a LeetCode every single day. I'm tired. I finished. Goodbye. Have a good day. See you tomorrow.